FatiguePlus is a fatigue life analysis software for pressure vessels, boilers, heat exchangers, mechanical components at elevated temperatures, as well as other structures subjected to cyclic loading. This tutorial provides a step-by-step demonstration for Basquin fatigue analysis using FatiguePlus. A mechanical component made of ASTM A36 is loaded with cyclic, von Mises stress history in one event as follows: -20, 10, -30, 50, -10, 30, -40, 40, -20. The unit of the stresses is megapascal. The stress history is taken from figure 6 of ASTM E1049, standard practices for cycle counting and fatigue analysis, amplified by 10 times. To calculate fatigue strength reduction factor KF, consider a corrosive environment factor of 0.9 and a notch effect factor of 0.7. I am going to use Basquin model and Goodman mean stress criterion and calculate the fatigue life of the component. Click New button on toolbar. Check Manually Input Radio button. The Use Stress Type Group box is for ANSYS result file option. Checking any radio button in this group has no effect on manually input project, so ignore it. Click OK button. From the Stress Unit drop-down menu, choose MPa. From the Stress Method drop-down menu, choose von Mises stress. In the Input Editor area, enter the stress values. The numbers are separated by comma, or semicolon, or space. Note that the stress count turned from 0 to 9 now. Click OK button. Now the project is created and the home window displays. The default unit of time is second. Click Radio button step to switch the unit of time to step. Click Project Setup button to select fatigue model, mean stress criterion and other project information. Select Basquin from Fatigue Model / Code drop-down menu. Select Goodman from Mean Stress Criterion drop-down menu. The bin size bin box is used for Rainflow cycle counting. Bin size is the number of bins in stress range histogram and fatigue damage ratio charts. Changing this value will not affect calculation results. Rather, it only changes the presentation of the results. Leave it to default value 18. The von Mises radio button in Basquin basis group box is automatically checked because von Mises stresses were entered. The other option principal stress is not applicable. Because non-proportional loading is not applicable to Basquin model, the proportional radio button in loading type group box is automatically checked by the program. The stress type labeling group is for labeling the charts if the user chooses to show node or element number on the charts. Checking any of the radio buttons has no effect on the analysis results. This group is useful when ANSYS FEA results are used. Select report type by checking Summary, or Report, or Detailed Report radio button. In this tutorial, we only want to see the summary. If you want to see calculation details, select Detailed Report instead. The project information, such as project name, job number etc. are optional. We just skip this step. Click OK button to return to main window. Now, click Fatigue Model Input button to select Material Properties etc. In the Select Material drop-down menu, select ASTM A36. The material properties are retrieved from material database and displayed in the boxes. The fatigue curve for the selected material can be plotted by clicking Plot Fatigue Curve button. You can zoom, print, or export the chart or change the styles of the chart by clicking the buttons on the toolbar. Click cross button on the upper right corner to close the window. To calculate fatigue strength reduction factor KF, click Calculate button. The fatigue strength reduction factor KF calculator dialog window displays. The default values are 1.0. Change CC, corrosive environment factor, to 0.9. Change CF, notch effect factor, to 0.7. Note that the KF value is automatically updated to 0.63, which is the product of 0.9 and 0.7. Click OK button to confirm and return to previous window. Now, click Fatigue Life Calculations button to run the calculation program. The program starts fatigue calculations. Now the calculations are completed successfully. The output information window displays summary of the results. As you can see, the damage ratio is 8.34 times 10 to the minus 8th power. The fatigue life is 1.2 times 10 to the 7th power repeats of block. The block is the loading time history previously entered, as you can see from the chart. Reminder, don't forget to save your work by clicking Save button. Click Report button to open the result report file. You can see from the report the input data, the stress cycle counts, stress ranges, fatigue damage ratios, and calculated fatigue life in repeats of block. Or you can call it a number of cycles of event. Click Time History button to view stress and temperature time history chart. You can turn off or turn on any of the curves by clicking checkboxes on the control panel. You can change the style of the curve, for example, the background of the chart. Let's change the black background to white color. Click Histogram button to view stress range histogram. The chart shows cycle counts for each stress range band. The stress range bands are grouped by the program using Rainflow counting algorithm. The histogram is an approximate representation of the distribution of stress ranges. Recall at the beginning of this tutorial, we set 18 bins to divide the entire range of values into a series of intervals. The program counts how many values fall into each interval. The vertical bars represent the frequency, that is, the number of cases in each bin. As you can see from this example, 5 bins have values, the rest bins are empty. From left to right, the 90 MPa bin has 1/2 cycle. The 80 MPa bin has 1 full cycle. The MPa bin has 1/2. The 40 MPa has 1.5 cycles. And finally, the 30 MPa bin has 1/2 cycle. Now, click Damage Ratio button to view fatigue damage ratios. The blue line in the chart represents damage ratio by each stress range bin. For example, the first point to the very left represents a damage ratio of 4.43 times 10 to the minus 8th power, created by the 90 MPa stress range. The second point represents a damage ratio of 3.65 times 10 to the minus 8th power, created by the 80 MPa stress range, etc. Please note that each dot in cyan color represents a bin. There are 18 bins as we mentioned earlier. The red line in the chart represents cumulative damage ratios. The cumulative damage ratios are successive additions of damage ratios created by individual stress ranges in 18 bins. The last point to the very right represents the total damage ratio of 8.34 times 10 to the -8th power. The charts can be switched from the window menu. To return to the home page, click Home button. That's the end of this tutorial. Thanks for watching. For more information, please visit our website at fatigue-life.com or fatigue.life.